Good afternoon, everyone. This is Shauna, and I'm coming to you this afternoon with an example of Chebyshev's theorem. I know that some of you had some difficulty with that, so let me share the screen. And the problem that I'm going to be doing here is a problem from your 3.2 homework. I'll be doing another one as well. That's not from your homework, but the problem that we're going to be doing right now, it reads this way. Let me put it on the screen for you. So it says, in a distribution of 160 values with a mean of 72, with a mean 72, at least 120 values fall within the interval from 67 to 77. Approximately what percentage of values fall in the interval from 62 to 82. 82. There we go. Use Chebyshev's theorem. Okay. Now, you have begun to look at the normal distribution as well, the bell curve. And so you've learned about the empirical rule. And I want to point out something here, that the empirical rule, the bell-shaped curve, that the empirical rule that you learn with the other percentages, and look for an example of that in another video coming shortly. But that distribution, the empirical rule applies. Chebyshev's theorem is more conservative because it doesn't matter what shape the distribution has. I could have a distribution where my distribution could look like this. I could have a, whoops. I could have a uniform distribution. For those of you who remember or might have seen that before, I could have a bell curve. So, and maybe it's approximately bell-shaped like this. I could have another distribution, say, that's skewed like that, for example, right? It doesn't matter. Chebyshev's theorem, the shape doesn't matter. It's more conservative in that sense. So you don't have those percentage constraints that you had with the empirical rule. But let's move on here in this particular distribution. This is a little bit hard. What I suggest you do with Chebyshev's problems is you kind of draw it out, and you can kind of draw it out on a number line so you can see what's going on. So I'm going to go ahead and draw a number line here. And we don't know what kind of distribution this is, but just to help us visualize this, go ahead and put your mean or your average in the middle of your line, okay? So generally with the Chebyshev's theorem, you're going to have 5 or 6 elements to it, okay? And you're going to be given some of those elements. You're going to be asked to find other elements. The elements that you're going to have or need to find might be the following. So you're going to have a percentage, okay? You're going to have an X minimum. You're going to have an X maximum. Sometimes the X min and the X max come in the form of the range. It'll say find the range of values in which 75% of the data falls, something like that. So you'd have a percentage in X min and X max. Then you have an S, which is the value of the standard deviation. And I'll explain why I'm writing it like that in a minute. And K, which is the number of standard deviations, between the mean and either X min or X max, okay? So S and K, whoops, excuse me, S and K get confusing sometimes for this. That's why I want to point them out here. So what we're looking at with this, let me continue here. So in a distribution of 160 values with a mean of 72. Now, mean is another name for average. So if you see, we have different kinds of means in this chapter. We have arithmetic means. We'll have you might have heard of some other means, but here in this class, we're going to use mean and average interchangeably pretty much, okay? Especially in coming chapters. So the mean here is 72. So what I'm going to do is I'm going to put 72 on that line, okay? Now, at least 120 values fall within the interval from 67 to 77. So somewhere out here, we have, and I'm going to leave myself some room because I'm going to need another number pretty soon here. But I'm going to leave myself a bit of room. This, I'm going to call this line 67. And I'm going to call this line 77. Try to make it even. Let's see if I can do a better job. Come out here just a bit. There we go. This is going to be 77. So now we have 67 here, and we have 77 over here, okay? Now, the next thing it says is approximately what percentage of values fall within the interval from 62 to 72. Now, this is a little interesting because we're going to have actually 2 percentages, okay? And I'll show you that if you haven't picked up on it, I'll show you that in a minute. This is 62. And this is 72 over here. So now we really want to know, I can use that. I can use this one. So I'm going to say that this is 82, right? So we know some things, but we don't know enough yet. This is 82, right? Now we want to know what percentage of values fall in this interval from 62 all the way to 82, but that's not the interval that we have. The interval that we have is the interval from 67 to 77. So what I'm doing here, going to draw us a little reminder here. We have this interval here. This, now we don't know this percentage, but we do know that we have 120 values in here. So the first thing we have to do is find our percentage of values, because knowing how many doesn't help us in this problem. So I'm going to find a percentage first. So I'm going to say that my first step here is to say, all right, this is my percentage, and this is for the interval, the percentage for the interval from 67 to 77, okay? That's going to be 120 values divided by the total number of values that I have, which is 160, because it says in a distribution of 160 values. If you work that out on your calculator, 120 divided by 160, this reduces to 3/4, which is 0.75, okay? Or if you want to make this a percentage, it's 75%. Now, if you go back to the slide for this lesson, when you go back to the textbook, you'll see that when your P, your percentage, so our percentage here was 75%, you'll see that when your percentage is 75%, that your K is 2, okay? So here we have 2. Now this is 75%, so we're going to put that in there, okay? You can also do this by solving it mathematically, but she gave you that. So this is 75%. All right, so let me go on to the next part. So I know that there's 75% of data in here. Now, the next thing I can do is I can look for I know what my X min and my X max are for this interval. X min is 67. X max is 72. So here I have 67 and 72. Now, I don't know what the standard deviation is. I do know what K is. And remember, I know what K is because that's implied in the percentage. Again, if you go back to the slides, let me stop sharing here and pull up the slides for this lesson and show you what I'm talking about. So if I say, there's the slide. All right, so now let me go here and pull up here's the slides for this lesson. If you look at the last part of this lesson here on number Slide 20, Chebyshev's theorem, okay? Here's your percentage formula, 1 minus 1 over k squared. For k equals 2, we have a percentage of 75%, okay? So we know that there's 75, so that implies the k is 2, all right? This means that our data is 2, so there's 2 standard deviations now between 67 and 70. So this piece here, this implies k is 2. Now let me show you how to find S. Now S is the actual standard deviation. So if you look here, you have, so we're going to have a mark here, right? Because we have to be 2 standard deviations from the mean. Remember that 72 is our mean here, right? So this needs to be our mean. So what I'm going to do, I'm going to say, here's my text box. Now you can use either formula. We can say that X minimum is equal to the mean minus KS, or you can use X max is equal to the mean plus KS, sorry. So doesn't matter which one. Sometimes we have one or the other boundary. Here we have both. So you can choose. I'll use the minimum. I think if you look back at the tutoring video, I used the max. So I'll go ahead and use the minimum here. This is 67 is my minimum at this point, because remember, I'm looking at the interval from 67 to 77. So 67 minus, equal the mean, which is 72, minus 2S. And this is where I made my mistake. I think I made this 1S before, but this should be 2S. Your K should be 2.5. Let me show you why. So we're going to solve this equation just like algebra. This is our nod to algebra at this point. So we're going to subtract 72 from both sides. So 67 minus 72 is equal to 72 minus 72 minus 2S. Now, here we end up with negative 5 is equal to negative 2S. And therefore, S is, if I divide by 2 on both sides, I have 5 over 2 is equal to, sorry, these should be, technically, these should be negative because they are, should be negative 5 over negative 2 at this point. And I have, this is negative 2S, and I'm dividing it by 2. So what I end up with is 5/2 is equal to S. And 5/2, if you use the calculator, is 2.5 is equal to S. So what that means is that there are 2.5 units for each standard deviation. So for example, this here would be 69.5 units. This is 69.5 if you put it on your number line. And this, I would have another one over here. There's another mark. This mark here would be 74 and a half. So I would have 74 and a half over here. Okay. So now you can see that we have now my value of S is 2.5 units. And you can see that from the minimum, right, of my interval, my green interval, to the mean, there are 2 standard deviations. 1, 2, 1, 2, 2 on each side, a total of 4. S is 2.5. So now if S is 2.5, okay, so I now know I can fill in that piece of information. The value of the standard deviation is 2.5. So let me switch whiteboards here. Let me go on and save my whiteboard for you. I'm going to go to a second whiteboard here. So based on what I now know, I have the following. I have use black here. So I have okay, that'll work. Am I gonna draw? Okay. So okay, whoops. All right. There we are. Now we have some other hash marks to make. Try to make them fairly uniform for you. Actually, I want to start by making that. Make one in the middle here. And then I'm going to make one here. And make one here. Okay. So what I have is the following. I have 62. And then I have, we'll come back to this in a minute. This is going to be 64 and a half. This is going to be I need to move this over and make a couple of more marks. Let me make a mark here. Oops. Put them there. And a mark here. I might need another mark. Okay, let's see. So this is going to be 67. This is going to be 2.5. So this is going to be 69 and a half. And this is going to be 72. So I have 67, I have 69 and a half. I have 72 after that. 72. I have 74 and a half. And then I have 77. I'm gonna erase this mark, bring it closer. So this is what my picture would look like. You can put this on the previous picture. I just didn't want to crowd the screen anymore. So this is 77. So now we know that we're going out 2 more standard deviations from here. So I'm going to go ahead and make this line a little bit longer so we can see what we're doing here. I need to make it a little bit longer here. So I'm going to put a line mark here and another at the end, which is there. I know this is not to scale, but this is 79 and a half. And this is 82. Okay, and you can get that just from adding 2.5 every time you do it. So now we know some things. We know what the standard deviation is, just to remind you. But we want to know now we want to do some work on the second interval. So since we've worked on this, we know some things. We now know that K so for the interval for K equals, let's say, for the interval from 67 to 77, K is 2, right? And we know that the standard deviation, which is S, is 5/2 or 2.5, right? Now, we're going to be looking at a different interval now. We're going to be looking at the interval from 62 to 72, which is what the question actually was. So the question was actually asking us, if you remember, the question was asking, what is the percentage, the minimum percentage of values between 62 and 82? Okay. Well, K is different, obviously, because remember, here's the mean right here. Now we're further away from the mean than we were before, because this interval is wider. So we are 1, 2, 3, 4 multiples away from the mean here. So we're not 2 anymore, we're 4 units away. To show you that, I can do this. I can say, well, all right. So I can, but my standard deviation remains the same. That's why I could draw the picture this way. So now, for the interval that we want, okay, so I'll put it over here. For the interval from 67, or 62 rather, 62 to 82, we can say that either, remember, x min is equal to the mean minus ks, or I can say that x max is equal to the mean plus kx. Now remember, my mean is still the same. My S is still the same. My standard deviation is 2.5. My K will be different here. I'm looking for what K is, all right? So here I need to know to calculate the percentage, find K. So find K for the interval from 62 to 82, right? So I'll do the max this time since I did the min last time. So 82 is equal to the mean, which is 72, plus K, which I don't have, times 2.5. Okay. So this is, again, I'm going to subtract 72 from both sides. So I have 82 minus 72 is equal to 72 minus 72 plus, and I'm going to write this as 2.5K, just so that it's a little cleaner. This is a difference of 10 is equal to 2.5K. And if you then divide by 2.5 on both sides, you will get 4, which is what the picture predicts. So we're going to divide here by 2.5, and we have 2.5 here and 2.5 here, and we end up with K equaling 4, right? So now we can do the calculation. So what is the percentage? Well, in terms of getting my answer is going to involve using the formula, which, let me remind you here, that the formula for Chebyshev's theorem is 1 minus 1 over k squared. Now this k is going to be 4 because we're using the longer interval. So let me go back. We're going to plug that in. We have this. This is going to be okay. So we have P is greater than or equal to, because remember it's at least, so it could be larger, 1 minus 1 over k squared, and k is 4 this time. So we have this, and so this becomes 1 minus 1 over 16. And if you work that out, you end up with hold on, let me stop sharing and bring up the calculator for us. So I'm going to bring up the calculator here. Okay. There it is. Bear with me for a moment while the calculator opens. And I will show the screen. And I'll show you where we get the calculation from. So this becomes, let me clear the calculator out. And I have 1 minus 1 over 16, or 1 over, if you'd like, 1 minus 1 over 4 squared. Can either use the caret symbol here, or you can use the x squared key. I'll use the x squared key here. And this becomes 0.9375. Okay, so here we have our shared screen, whiteboard. Okay, so now this becomes, and it asks for a percentage, not a decimal. So we're going to have to convert this 93.5, and then your percentage, if this is a percent, remember you're going to multiply that by 100, which just means the decimal point will move over twice to the right. This is 93.75%. This is about as difficult as a Chebyshev's problem can get. So if you found this problem a little bit of a challenge, I'm not surprised. The mistake that I made when I did it last night was I didn't show this second partial step properly. I told you K was 4, but I didn't tell you exactly why. So if you want to go back to the whiteboards, I'll make sure that I make those available to you. But the answer is 93.75%. Okay. I hope that this video has been helpful to you, and I look forward to seeing you in my next video. Thank you, everyone.